Hi everyone, we're going to be talking about how to distinguish among different atoms. So just like there are different dogs in the world, of course I'm going to include dogs, there are different varieties of atoms. So there are actually 4 different types of dogs in this picture, but we know that they are different based on some of their physical properties. With atoms, we use different things like atomic number. The atomic number is the number of protons in the nucleus of the atom. So remember, the atom has a nucleus, and then surrounding that is the electrons, and inside of this nucleus you have lots of positive protons. And that number differs based on what atom you're looking at. So, for example, if you have a hydrogen atom, its atomic number is 1. That means that it has 1 proton. So anytime you're using atomic numbers, remember that the number of protons equals your atomic number. So if you look at another one, so if you were to find oxygen, you would have an atomic number of 8, which also tells you that you would have 8 protons. Now, remember, atoms are electrically neutral. So whenever you look at the atomic number, so remember the atomic number is equal to the number of protons. You can also figure out how many electrons there are. So let's go back to the idea of oxygen. So with oxygen, your atomic number is equal to 8. That means, according to our definition, that we have the number of protons is also equal to 8. Now, protons are positive. So if there were only protons in an atom, this one would have a charge of positive 8. However, atoms have to be neutral. So in order to cancel out all 8 of those positive charges, we would have to have 8 negative charges. And that's how we figure out the number of electrons. In order to make something neutral, you have to have the same number of protons as well as electrons. Additionally, we can look at another one. So here we have an element of nitrogen, and it has an atomic number of 7. So automatically remember our definition that the atomic number is equal to the number of protons. So that means that if you have an atomic number of 7, that means that you have 7 protons. Now remember, we have to keep it neutral. So if we have a positive charge of 7 protons, we would have to have a negative charge of 7 electrons. And if you ever need to check, you can take a positive 7 minus a negative 7, and you should get 0. That should make you happy because you are a neutral atom. And this is also broken down in the PowerPoint. It takes you through each step by step, just in case you forget. Now we get a new term. So it's very easy to get these guys mixed up. So think of mass as how much something weighs. So you're going to have really, really heavy things coming into play. Now, electrons are super teeny tiny, so we're going to ignore them completely with our mass number. However, according to our last chat, we have these things called protons and neutrons that weigh about the same amount. So our mass number is equal to the number of protons plus the number of neutrons. This number will always be a whole number, meaning that you will not have a decimal. And you will, it also will be larger than our atomic number, since our atomic number is the number of protons by itself. So if you know the atomic number and you know the mass number, you can determine exactly what's happening in that atom. The number of neutrons in an atom is the difference between the mass number and the atomic number. Another way to think of that is, remember, our mass number is the number of protons plus neutrons. And our atomic number is the number of protons. So if you subtract the number of protons from the number of protons plus neutrons, according to math, these two cancel out, and you're left with only the number of neutrons. So we can actually give that a try, but first you have to know how to write the composition of any atom. So anytime we are writing an element, your atomic number, or the number of protons, is going to be a subscript. So if you look at our element of gold here, our subscript is 79. That tells you your atomic number. Whereas your mass number, remember, that's the number of protons and neutrons, is going to be a superscript. And I like to think of the Superman, how he's always higher. So our superscript is going to be higher, and you can see that in our picture here with 197. So let's give the first one a try. So let's look at letter A first. And right now we're trying to figure out how many protons, electrons, and neutrons are in each atom. So if we want to remember, if you need to do this on a test, feel free. Your mass number is going to be your superscript. Your atomic number is going to be your subscript, and then your symbol is going to be the large letters. So if we remember that, our 9 is going to equal our mass number, and the 4 equals our atomic number for letter A. So first off, we know that the atomic number means the number of protons. And to determine the number of protons, all we have to do is drag that 4 over. So the number of protons is equal to 4. And remember our first step, we have to have a neutral atom, so the number of electrons must also be 4. Now the tough part, we have to figure out how many neutrons. So if you recall, the mass number is protons plus neutrons. So the easiest way to figure out how many neutrons is to simply subtract. 9 minus 4 is 5. That means we have 5 neutrons. If you need to check, add the number of protons plus neutrons, which would be 5 plus 4, and you would get 9, just as in our example above. So let's try the next one. Let me erase here really quick. Okay, so let's try the same idea with letter B. Remember again that the top one is our mass number, and our bottom one is our atomic number. Okay, so if we have a 20 on top and 10 on the bottom, the 10 shows you that that is our atomic number, which also shows you the number of protons. So the protons would equal 10. Our electrons have to equal the protons in order for it to be neutral, so that also equals 10. Then you simply subtract to figure out how many neutrons. And if you need to double check, we can take the protons plus our neutrons, so 10 plus 10 equals our superscript of 20. Okay, and finally for the last one, again, we have our mass number on top, our atomic number on the bottom. So that means the number of protons is equal to 11. To make it neutral, we have to have electrons equal 11. Then we simply subtract to get 12 for our neutrons. And this is also completed in the notes as well for you. If you want it broken down even more, you're more than welcome. It's also takes all the same notes that we just went through. Now, something that's kind of interesting is that we can have different kinds of the same atom. So these are called something different. These are called isotopes. And isotopes are a little bit different, but they always have the same number of protons, because protons give something their identity. That's just like how your name is kind of how you are called your identity. Protons are the atomic version. So if you look, each one of these has the same number of protons. They also have the same number of electrons because they are neutral. But where they differ are in how many neutrons they have. So all isotopes are the same atom with different numbers of neutrons in their nucleus. Because they have different numbers of neutrons, they also have different mass numbers. If you recall, your mass number is the number of protons plus the number of neutrons. So since we have different amounts of neutrons and the same number of protons, we're going to get different isotopes. So despite these little differences, we're going to have the same type of chemical compositions because they have identical numbers of protons and especially electrons. Those are what are responsible for chemical behaviors. So the only thing that's different is the mass number. And that's also shown in this slide right here in your notes if you didn't catch all of that. Whenever you go to write a chemical symbol for an isotope, remember it has the same number of protons. It has the same number of protons, which I will tell you from the periodic table that the atomic number for carbon is 6. We will be able to write their element based on how much their mass number is and their atomic number. So if you recall, your mass number goes in your superscript, your atomic number goes in your subscript, and then your big symbol. So for each one of carbon-12 and carbon-13, they're both going to have the same atomic number since the number of protons are the same. So if I wanted to start out, I'm going to start with my symbol of C for carbon, which comes from the periodic table. My superscript is the number 6 for both of them. Now the difference is how much they weigh, or their mass number. So for carbon-12, that already tells you the mass number. So you simply translate that into our superscript. For 13, that's also telling you the mass number. And you simply drop it down and put it into the correct superscript position. And again, that is all described to you in the notes as well. And as always, you have these great informations at the end of the different vocab words that we went throughout this lesson. All right, I'll see you tomorrow.